Hello, everyone. You might think bigger models mean better AI, but there's a surprising truth here. Let's explore it together. These days, everyone focuses on larger models with more parameters. However, the real challenge lies in memory, how much context the AI can retain. Think of it like your own brain, short term memory for immediate tasks and long term memory for stored knowledge. AI faces a similar balance. Now let's dive deeper. What exactly is a context window? This is one of the most important concepts in understanding how AI works. Think of a context window like the AI's working memory or attention span. Just like you can only remember so many things at once, AI has a limit on how much information it can hold in its mind at any given time. Let me give you a simple example. Imagine you're reading a book. How many pages can you remember clearly at one time? Maybe just the current page or a few pages before it. That's similar to what the context window does for AI. The context window is literally the amount of text the AI can remember at once. If you give it more information than its window can hold, it starts forgetting the earlier parts. So the bigger the context window, the more information the AI can keep in mind while working on a task. This is why context window size matters so much in AI performance. Now that we've seen how context windows affect AI's memory, let's break down the basic unit they use: tokens. Think of tokens as the Lego bricks of AI. Each one is a small piece of text that the model processes. Each token is roughly 4 characters or 3/4 of a word. This means even short phrases are broken into these chunks. As you can see here, the context window measures how many tokens the AI can handle at once, like a puzzle with a fixed number of pieces. For instance, hello world might be 2, 3 tokens. This shows how token count varies based on the text. Understanding tokens helps us grasp why context window size matters. It's all about how many of these building blocks the AI can work with at once. Building on what we just covered about tokens, let's visualize how an AI's memory actually works with this interactive window. Go ahead and drag the slider at the bottom to change the size of the context window. When you make the window large, you can see the whole story clearly because there is enough space for all the tokens. Now try shrinking the window by moving the slider to the left. Watch how the text starts to fade away on the left side. This shows information the AI has forgotten because it no longer fits in memory. Understanding this limit is crucial because next we will see how technology has grown to handle much larger amounts of information. Look at how AI memory has changed over time. As you can see from this title, we're going to explore the dramatic growth from. Think of it like how your phone's storage has grown from tiny amounts to being able to hold entire libraries of information. In the early days, AI models could only handle about 512 tokens. That's roughly a short paragraph. Imagine trying to read a whole book but only being allowed to remember one page at a time. But today, modern models can handle thousands to even millions of tokens. That's like being able to read and remember entire books in one go. And here's the amazing part: all this growth happened in just a few years. Technology has moved incredibly fast. This expansion in memory capacity is what allows AI to understand longer conversations, read full documents, and remember more context. But as we'll see next, bigger isn't always better without challenges. Now let's dive into the first challenge with larger context windows: increased costs. Remember how we discussed tokens as the building blocks of AI understanding? Well, here's where things get expensive. Each token requires computation. More tokens mean more work for the AI system. Think of it like printing a book. A 10-page document costs less to print than a 500-page novel. Same principle here. Notice this comparison. Small context windows stay affordable, but large ones, they can cost hundreds of times more. Processing a million tokens isn't just slightly pricier, it's a whole different ballgame. See this visual? The cost curve isn't linear. It spikes dramatically as context grows. That's why developers and users both feel the pinch when scaling up AI capabilities. This isn't just theory. Companies building AI tools must balance context size against budget constraints. For users, it means longer conversations or document analysis could mean higher bills. So while bigger context windows solve memory challenges, they introduce financial ones. Next, we'll explore how this affects response speed, another critical factor in real-world AI use. So we just saw how larger context windows can increase costs. Now let's look at another challenge: slower responses. This is what we call problem 2. Here's the key issue: more tokens to process means longer wait times. Think of it like reading a book. The longer the book, the longer it takes to read. To give you a concrete example, a model with 1 million tokens might take 10 times longer to respond than one with just 100,000 tokens. That's a significant difference. This image shows how processing time scales with token count. Notice how the wait time increases dramatically as we add more context. Here's why this matters. Users expect fast answers. Nobody wants to wait 5 minutes for a simple question. Speed is crucial for good user experience. So while larger context windows give us more memory, we need to balance that with response speed. This is the trade-off developers face when building AI systems. Now we've talked about cost and speed issues with larger context windows, but there's a third problem we need to understand: more hallucinations. A hallucination happens when AI makes things up or gives wrong information. It's like when someone confidently tells you something that isn't true. Here's why this happens. When you give AI too much information, it gets confused about what's actually important. Think of it like trying to remember everything from a 500-page book. This image shows how overwhelming too much context can be. When AI tries to process everything at once, it starts mixing up facts and making mistakes. So while bigger context windows give us more memory, they also increase the chance of AI getting confused and hallucinating. It's another trade-off to consider when building AI systems. Now that we've seen the three main problems with large context windows: increased costs, slower responses, and more hallucinations, let's look at how we can solve them. This is where smart optimization comes in. The goal is simple. We want to reduce the number of tokens we send to the AI while still keeping all the important information intact. Think of it as making our data more efficient without losing what matters. There are two main techniques we'll explore: context summarization and quantization. These are the tools that help us compress information smartly. Here's a helpful way to think about it. Imagine you're packing a suitcase for a trip. You want to fit everything important, but you also want to make it compact. You keep the essentials, fold things tightly, and remove unnecessary items. That's exactly what these optimization techniques do for AI memory. This visual helps illustrate how we can organize and compress information efficiently, just like packing that suitcase. In the next 2 pages, we'll dive deeper into each technique. First, context summarization, then quantization. You'll see exactly how they work and why they're so effective. Great! Now let's dive into our first solution: context summarization. This is one of the most straightforward ways to handle large amounts of text. Here's how it works. The AI reads the full text and creates a shorter summary. It keeps the main points but removes all the unnecessary details. Think of it like this image shows. Imagine you have a 500-page book, but instead of reading every single page, you just read the summary at the back. You still get the main story without all the extra details. This means the AI doesn't need to remember everything word for word. It only needs to remember the key points, which takes up much less space in the context window. So we've got three benefits here: less cost, faster responses, and fewer mistakes. The AI can focus on what really matters instead of getting lost in all the details. Now let's move on to our second solution, which works in a completely different way. As we saw with the first solution, context summarization helps reduce data. Now let's explore quantization, another powerful way to optimize AI memory. Quantization works by compressing the AI's internal numbers. Think of it like reducing the precision of calculations to save space. Imagine converting a high-resolution photo to a smaller file. You lose some detail, but the image stays mostly the same. That's exactly what quantization does for AI models. This saves a lot of memory while keeping most of the model's quality. It's a smart trade-off that makes AI faster and cheaper to run. So quantization is all about efficient compression, just like optimizing a photo for web use without losing too much clarity. Now that we've covered quantization, let's see how these optimization techniques work in the real world. You might be wondering, where do we actually use these ideas? Context optimization helps AI work better across many different situations. Let me show you three practical examples. First, customer service AI. When you call a company, the AI can summarize your entire conversation history. This way, it remembers what you've discussed before without needing to load everything every time. Second, legal document analysis. Lawyers can process long contracts efficiently by summarizing key sections. The AI keeps the important details while reducing what it needs to remember. Third, research assistance. When scientists read multiple papers, the AI can handle all of them without losing context. It's like having a smart notebook that organizes everything for you. These examples show how context optimization makes AI more practical and useful in everyday situations. We'll wrap up with key takeaways on the next slide. Now let's recap the key takeaways from our lesson on AI memory and context windows. First, remember that the context window is like the AI's working memory, measured in tokens. Just like you can only hold so much information at once, AI has limits too. Second, a bigger context window means higher costs, slower responses, and more chances for the AI to make mistakes, which we call hallucinations. Finally, techniques like summarization and quantization help optimize performance without losing quality, making AI more efficient. These points tie together everything we've learned. Throughout this video, we explored AI memory fundamentals, from context windows and tokens to optimization strategies. Now let's preview what's coming next. Our next video compares RAG and memory systems to determine which approach is more effective. After that, we'll examine real-world AI memory architectures to see how they work in practice. To stay updated with these insights, please subscribe to our channel so you don't miss a single episode. Thank you all for your engagement today. You've built a solid foundation in AI memory concepts. See you in the next video.